So this is the first example where we try to demonstrate the basic RAG pipeline using a completely local knowledge base. This Mistral bot is an extension to the previously demonstrated Mistral bot. This bot is enhanced with the RAG pipeline. So let's quickly run and see how this works, and later we will go in depth of what are the major building blocks of this RAG pipeline. Let me go to terminal. Mistral RAG bot static knowledge. Okay, let me show you while it's running. So this is the project structure of this RAG pipeline. We have this RAG static knowledge where I have kept one PDF document here, Little Red Riding Hood, a small story for kids. And we will use this as a knowledge base. We'll ask few queries to language model and see how it responds. The bot is running. Now I can ask who is the lead character of the story. So it went to fetch. It said Little Red Riding Hood. Okay. Before asking queries, let me give a brief of this story. Let me open this PDF so that you will understand. The story is about a small kid, Little Red Riding Hood. His grandma is not feeling well, so his mother sent him with some bottle of fresh milk, bread, and butter to give it to his grandmother. So on the way to his grandmother's home, he will come across a cunning wolf, and the wolf says, "Go pluck some flowers." And meanwhile, the wolf goes to the grandma's house and eats her. She tries to be her grandma, and she wants to eat this little kid also. And finally, some other person who is on the forest help cut the wolf. These both persons sprang out of the wolf. So that's how the story ends. Let's go back to the demonstration. So that's why it said Little Red Riding Hood, the lead character of the story. Where and why the Little Red Riding Hood is headed. It said the Little Red Riding Hood is headed to her grandmother's house. She is carrying a basket of food for her grandmother who is sick. This is 100% accurate from the PDF what is fed to this RAG pipeline. This is a small example. And let me ask one more final question. What happened finally? Because we are running on a low computational power system, we have given a small PDF document, but if we have a good computational power, we can go for a huge document, many paragraphs, many pages, so that this language model will be able to process context and will be able to answer our questions. So finally, the assistant answered as the wolf ate grandma according to the traditional ending story. However, there are alternative endings that have been developed over time. One popular alternative ending is that grandma outsmarts the wolf by leading him into a trap or pot of boiling water, and then she is able to escape and save herself. This is something hallucinated by the model, but we can ask one more question straight away. What is alternate ending of the story? An alternative ending of the story is where the wolf is defeated by the woodsman. The woodsman hears the wolf's laughter and follows the sound to find wolves in grandma's house. He shoots the wolf and saves the grandma, Little Red Riding Hood. In this version, the wolf is punished for its action on grandma. This is how a classic RAG pipeline works. Now let's go to the core building blocks of this classic RAG pipeline. As a first step, we call this bot. We give the static knowledge directory. So whatever documents are there in this directory will be fed as a knowledge base to the language model. That's the idea. I have given this as per my system's document directory and this projects directory. You can change it to once the Mistral bot is initialized with this directory, then as a first step, we initialize the static knowledge and then we load this with the contents of the static directory. So as soon as we start loading it, right, so we have some predefined file formats which are supported to read the text out of the files. Using these files, we'll process them and extract the text from either image, PDF or text source files. And once we have the data, then we add it to a vector database. So this is the key element as part of the RAG pipeline. So till now we have seen whatever the context or whatever the knowledge base we are setting to the language model is all in the live memory. I mean, if once the application is stopped, then there is no way we are going to get back them. So that's how they worked. But now we are bringing a DB here which is aligned with the language models, that is vector DB. This vector data is actually initialized as soon as the static knowledge is initialized. It holds a reference here. In this vector data store, it has all the key elements which are necessary to hold or transform the text into a vector database. So the key elements of this vector data store are, first thing is FAISS, which is Facebook's AI similarity search supported by Meta, where it can retrieve the data based on a simple keyword search, unlike the traditional databases. Sentence transformer, this is the first thing actually the text goes into, and it will convert it as an embeddings that is understandable by the vector database. So sentence formatter is a crucial part of this RAG pipeline. And then we have few configurational attributes, and this index is a part of FAISS to access the data with the similarity search. That's what this indexing is about. This part I'll explain later. This is for the persistent store. We'll see that in the later demonstrations. This is what happens as soon as we initialize the vector data store. When we actually try to add the documents, I mean list of text content, then first it feeds it to the embedder and encodes it and get the embeddings of it, of the data that we fed to it, and then it will add it to the index. This index is nothing but the FAISS reference. So it will add that embeddings to the vector database reference, and a doc store which acts as a metadata, actual data which we feed it to the vector data store. That's how we convert our documents to text and text to embeddings, and then we feed it to the vector database. So this is the usual process that happens in this RAG pipeline. Now we understood how the data is coming and sitting in the vector database. Now let's see this RAG pipeline of the Mistral bot. What happens when the user actually queries something? As soon as the user queries something, it comes here. The user input is fed to static knowledge class. It will retrieve based on the user input. Let's go to the static knowledge. It internally directly goes to the vector data store. So here that query comes to this vector data store, and here again it goes to this sentence transformer, pass the query, gets the query embedding of that. Okay, now it is also converted as an embedding. This query embedding is passed to the vector database reference, like how we query the SQLite or other traditional databases. Same thing happens here too, but with a similarity search. It doesn't have any specific querying parameters or attributes. So we simply pass the query in the form of query embedding, and we get the indices of it from the vector database. So here we get the distances and the indices. Using the indices, we get the reference of the doc store, I mean literal meaning of that index, which was actually stored in the doc store when we are adding the documents. Using these indices, we take the actual reference of the content which is present in the doc store, and we return as part of the retrieve class. Then the retrieval information reaches the bot system, and from here the usual process starts again. We set the context as a whatever data is retrieved, and then we build the prompt by setting the context and user input. And this is the usual process what we have seen in previous demonstrations as well. So this is how a classic RAG pipeline works locally with the static data reference. So if you are interested, earlier we also developed a ollama bot as well, which is shared in the previous demonstrations. I do have an example for that too. Go check that out, and how the classic RAG pipeline is easily integrated with ollama bot as well.